right? So we'll see types of solutions when we solve the given system of linear equations, what kind of solutions we'll get. Then we'll see Gaussian elimination method, and then row echelon form, reduced row echelon form, particular and general solution, minus one trick. We'll try to cover these things. Till now, we have seen how do we convert a given machine learning data. If I have ML data with me and I want to do a prediction task, I am able to convert that ML data into a system of linear equations, which in turn can be converted to a matrix form. Now I have to apply some matrix techniques which I've already studied, so that I can find out the values of W and B, and I can form a ML regression model which can help me in prediction, right? So as part of that, these things are not new. Maybe one or two, I feel these two are new for some people, but these four are very, very popular. You might have already studied in your graduation. So let's once again quickly recall these things, and then we'll try to go for the Python implementation. How do we solve given system of linear equations in Python? Okay, maybe just using some functions of Python libraries or packages, we'll try to solve them, right? So types of solution. First one, let's see types of solutions. Okay, so when you are given a system of linear equations, there are three possibilities. One, first one, you're getting unique solution. Unique solution means you're able to find out, given for the given data, you are able to find out single values of A, B, and C. This is what actually we want. Yes or no? When I said, when you're having multiple system of linear equations, your goal is to find out one regression model, one equation, y equal to 10x1, maybe something like this, y equal to 10x1 minus 4x2 plus some 3.2, multiple linear regression, for example. So I want to find out equation like this. When can I get this? You can get it when you have a unique solution. It means you have unique values of W1, W2, and B. Only then you form a regression equation. So this is my prediction model, ML model, regression model, which will help me in doing prediction, right? So one possible is you for when you are solving this system of linear equations, you may get unique solution. Second one, you may get infinite solution. And third one, no solution. Okay, so these three are possibilities for given system of linear equations. Okay, once again I repeat, these mathematical foundations are required when you do lot of research in machine learning, or when you go for placements where you apply for machine learning jobs or data science jobs, because these things are, I'm telling you, you'll be surprised at the end of this, after completing these things, when we see the Python thing. Why, you will ask me, sir, why do we have to solve all these steps in mathematics when Python is just giving me in 2-3 lines? You have one library, linear algebra, LIG, ALG. I have one library which can directly give me, I will say, given the matrix, if you remember, we are having Wx, W into x plus B equal to y. This is a vector, this is a matrix, this is a vector, this is a matrix, this is a constant, and this is a vector. So you give these two as input, vector and the matrix, it will tell you the values of W and B. In a single, it will tell you what is the solution. You want to find out determinant, single command, det, just you determinant of the array, it gives you determinant. Python, it's easy, but you should know what is the underlying, how it is being done. Somebody asks you to write a program to implement linear regression. Don't use the command of linear algebra package directly. You cannot use it. You have to solve it line by line. So types of solutions, simple concept. When you solve given set of system of linear equations, why are we talking linear? Because our data is in linear form. It can be represented as a linear. It cannot be represented as non-linear form. System of equations, we have seen how am I forming system of equations. System of sentences with numerical values are system of equations, right? So given system of linear equations, I can get three possible solutions: unique, infinite, and no solution, right? But what is our goal? Unique solutions. So you should have systems, you should have system of linear equation. It means you should have your ML data in a proper format so that you get unique equation, unique solution. When you get unique solution, you're trying to find out the values of W1, W2, and V. Then you form the regression model to prediction. Okay, this is types of now. Let's see the second one, Gaussian elimination method. Gaussian elimination method. This is one standard method to solve given system of linear equations. Okay, Gaussian elimination method. Okay, what is said? What are the rules of this Gaussian elimination method? Given a matrix, again I am saying matrix. What is this matrix from? Where is this matrix coming from? This is my actual data set, right? Maybe this contains the data of the suppose the size of this matrix is 3 cross 3, for example. This is the data of wind speed, temperature, humidity of 3 different windmills or at 3 different time intervals. Okay, so this matrix is my actual ML data, whichever I have, right? So this is a matrix given to me. What is this Gaussian elimination method? My target is to find out the values of the vector. I have a vector here, x, y, z. I have to solve. I have to find out the values of this x, y, z, or x1, x2, x3, or w1, w2, w3, whatever you say. If I can find out the values of x, y, z, I can form an equation. So to find out these values of x, y, and z, we can do some operations. You can perform row transformation operations. Row transformation operations. What does it says? Let's take an example. So given set of equations, let me take an example. You have x minus 2y plus z equal to 0, first equation. Then you have 2x plus y minus 3z equal to 5, 4x minus 7y plus z equal to minus 1. Suppose you have this equation. X, y, z are unknowns. Again, if you want me to talk purely in terms of machine learning, I can write this as W1 minus 2 W2 plus W3 equal to 0. Weights, W1, W2, W3 are weights. See, common, W1 is common. 2 W1 plus W2 minus 3 W3 equal to 5. Then you have here 4 W1 minus 7 W2 plus W3 equal to minus 1. So I have to find out the weight values. W1, W2, W3 I have to find out. If I can find out that, I can get a unique equation which can help me in doing prediction. So you have this. You have to convert this into matrix. How do I convert this into matrix form? You can convert this into matrix vector combination. So you take all the constant values here. So 1 minus 2, 1, 2, 1 minus 3, 4 minus 7, 1. This is my matrix and my vectors is this. I have x, y, z as my vector and this is my constants, that is y output. Okay, here we are not having the bias term. We have this matrix vector representation. Now, see, why are we learning Gaussian elimination method? Given a set of system of linear equations, you have to solve those equations, find out values of W1, W2, W3 and so on. 3 equations I can do it manually using some calculator or using some substitution method. I can do it. But if there are n number of equations, how do we do that? For that we apply Gaussian elimination method. But for easy understanding, we are taking a small matrix. It says that you do row operations. Condition is that you can do only row operations. You can perform operations only on rows. Second one, you can add, subtract the rows. You can add, subtract the rows. You can exchange the rows also. You can exchange the rows. So row operation means I can add two rows, R1 equal to R1 minus R2, R2 equal to R2 minus R1. I can do row transformations. I can do row operations. Second one, you can exchange the rows. Okay, you can multiply each row with a scalar. Maybe I can write, if this is row 1, this is row 2, this is row 3. I can multiply R1 into 2, R1 equal to R1 into 2. I can multiply first row with 2. Okay, so by this I have, my target is to solve it, right? By doing row operations, we can solve this and find out the values of x, y, z, right? For this problem, let us see how do we do row operations. You can perform only row operations. You can exchange rows if you want. You can multiply each row with a scalar if you want. Okay, you cannot do any operations on columns. That's what Gaussian elimination method says. So if I write a matrix in a shorter form, it is something 1 minus 2, 1, then I have here 2, 1 minus 3, I have 4 minus 7 and 1. This was my matrix, and I have x, y, z with the values as 0, 5 and minus 1. Now, to apply Gaussian elimination method, you have to form an augmented matrix. Augmented matrix. What is this augmented matrix? You have to see A x equal to B, right? This is in form matrix A, x, which I have to find out, and B is given. So if you have to combine A and B matrix to form an augmented matrix. So your augmented matrix becomes something like this: 1 minus 2, 1, and 0 also. This 0 I am including here. 2, 1 minus 3, 5, 4 minus 7, 1 minus 1. See, I am including the elements of A and B in a single matrix. This becomes my augmented matrix. Now you apply row operations on that. Can you please solve this? Can you tell me, can you reduce this matrix? Do row transformations. Do row. See, the ultimate target, okay, we forgot one point. The ultimate target here is to convert this augmented matrix into a upper triangular matrix. You have to convert this into an upper triangular matrix. It means you can have zeros here. You can have zeros like this, and remaining can be elements. So target is to form an upper triangular matrix, making these values as zeros. So you have to do such kind of operations such that this is 0 first, then this is 0, then this is 0. That way you keep trying it, try to do operations on this matrix and form one matrix. Can you just try this? Take pen and paper and try to solve this. Tell me what is the matrix which you get at the end. What operations can you do on this? I want to make this 0. So can I write R4 is nothing but R4 minus 4R1 is one operation. Then R2 is nothing but R2 minus 2R1. Why? My goal is to first make this 0 and this 0. How can I make this? Using R1 I can do it. R4 into R1 minus R4, if I do, this becomes 0. Right? By using these two operations, we can convert this matrix. Oh, sorry, R3. I am mistaken. R3. Because of this 4, I said that R3 equal to R3 minus 4R1, R2 equal to R2 minus 2R1. So with these two operations, maybe I may get a matrix something like this. If you can solve, if you are solving, please tell me what could be the values. R1 does not change, so it becomes minus 2, 1, 0. See, R2 minus 2R1. So 2 into 2, this is 0. 1 minus 2 into minus 2. So this becomes 5. Then minus 3. So minus 3 minus 2 into this value here, that is 1. So this becomes minus 5. Then 5 minus no change in that. So this remains 5. Right? Similarly, if you do R3 equal to R3 minus 4, I will just quickly write 0, 1, minus 3 and minus 1. This is what we get it. Right? Now, what is the next operation we can do? The easiest operation what we can do is that you can make divide R2, you can divide R2 by 5. So it becomes very easy because it becomes ones, which is easy to calculate. So 1 minus 2, 1, 0, 0, 1, minus 1, 1, 0, 1, minus 3, minus 1. Now, our next target is to make this 0. How can we make this 0? Can you subtract this R3 minus R2? If you do that, we may get this value as 0. If you can convert that, we may get value as 0. So if I convert R2, R3 is nothing but R3 minus R2 if I subtract, right? So I may get value matrix. If you do the operation, R1 remains same, 1 minus 2, 1, 0. This also remains same, 1 minus 1, 1, 0. 1 minus 1 becomes 0. Minus 3, this becomes plus 1. So minus 2. Minus 1, this becomes minus 2. Okay, so we get this. Next step, let me erase these matrices. Right. So after this, what can you do? I may apply R3, nothing but R3 divided by minus 2. If I do, then it becomes something 1 minus 2, 1, 0, 0, 1, minus 1, 1. This becomes 0, 0, 1, 1. Still, I think I can make few elements 0. It's up to us to make this 0. If you can just add this becomes 0, but it's our choice. You can make this 0 or not, right? Now we got this into a form, row echelon form, correct? Now you multiply those values. From this, you write, the equation has changed now. See, now again you convert this matrix into system of linear equations. How do you convert? X minus 2y plus z equal to 0, the first one. Then the second one, y minus z equal to 1. Then the third one, z equal to 1. 1 into z equal to 1, if I equate it. Z is 1. When z is 1, if you put z here, 1, y becomes 2. Y becomes 2. Z is 1. You substitute these two values. What is x value? X value here, y2 means 1 minus 4 plus 1 equal to 0. So this is x. So x minus 3 equal to 0. X becomes 3. So the value is 3, 2, 1. So what are the values of x, y, z? 3, 2, and 1. I hope you understood Gaussian elimination method. By doing row operations, we are trying to find out the values of weights. W1, W2, W3. We got the values of weights. Okay, W1, W2, W3. With this, we form a prediction model which can help us in finding out the new value. Given any input value, you can find it out. Okay, Gaussian elimination method. But this is again little tedious task. I am doing row operations here, right? I hope you understood. If you want to solve one more problem, maybe you can tell me by Gaussian elimination method. Please solve this problem. Solve x plus y minus 3z equal to 4, 2x plus y minus z equal to 2, 3x plus 2y minus 4z equal to 6. Can you just try this and tell me what are the values of x, y, z by using Gaussian elimination method? Okay, you can note it down, solve it later, and you can find it what is the solution for this given Gaussian elimination method, right? So the method is very simple. Do some row transformations. You can exchange rows. You can do operations on each row. You can multiply. You can divide the row with a certain scalar, and you can find out the solution for that. Okay, that way you can do it. But is there any other easiest way? Same thing. We will little go the Gaussian elimination method. It says that in the matrix, you form these values as 0. Suppose A, B, C, D, E, F. I have a matrix like this. Your target is to make these values as 0. Okay. This notation is called row echelon form. Row echelon form. Okay. This is called row echelon form. Right? And the rows with a single value. Oh, sorry, columns. I just corrected columns. Columns with single entry are called as pivot columns or pivot elements. So here A is pivot. A is a pivot element or pivot column, because in this particular column there is only one element. There is only one element. Such kind of rows or such kind of elements are called pivot element or pivot columns. Okay, so this notation, when you are solving a given system of linear equations, you are converting into matrix. You are trying to solve that matrix using Gaussian elimination method. You get a final matrix. That form is called as row echelon form. So your target is to convert a given system of linear equations to row echelon form so that you get the solution. Okay, row echelon form. It says that there should be zeros in this form. Upper triangular matrix should be formed and there should be zeros like this. Row echelon. Your target is to make this 0 first, then this 0, then this 0, and keep on doing it. Okay, but this is row echelon form. Simple. What is reduced row echelon form? Reduced row echelon form. More faster way of solving system of linear equations. Reduced row echelon form. So when somebody gives you a set of system of linear equations, you convert that system of linear equations to a matrix, then convert that matrix into this format, reduced row echelon form. You can directly get the solution easily. Okay, solution is very quick in getting it. In the previous case, if you see, in the previous example which I have explained, what we are trying to do, again you are getting 3 equations. When you converted that by applying Gaussian elimination method, when you converted that matrix to a particular row echelon form, you are getting 3 equations. Those 3 equations you are trying to solve them. Again, you are trying to solve those equations. So little effort is required there. This is 3 by 3 case. Assume 50 by 50 case. When you convert that 50 by 50 matrix into row echelon form, you get a set more number of equations. Again, you have to solve those equations. So it is little complex. So you can convert that row echelon form to little advanced version, that is reduced row echelon form. What does it says? What is reduced row echelon form? Don't stop your row operations, whatever techniques you are applying, no? R1 minus R2, R2 minus R3, don't stop it. You can see this is an example of reduced row echelon form. Suppose I have a matrix like this. I have matrix 1, 0, 2, 3, 0, 0 obviously. I have 1, 0. I have here 3, maybe 0 here, and 4 and 0. Suppose this is the matrix which I have got. Okay, or maybe I can take here as 1 and I will put this value as 2. Okay, after doing some row transformations, if I can convert that matrix, see which element, which column is called pivot column. This is called pivot column. This is a pivot column because there is only one non-zero element in any column. If there is only one element, that is called a pivot column. So this is a pivot column. This, in this example, this is a pivot column because there is only one non-zero element. Perfect. This is also pivot column because there is only one non-zero element. These two are not. So C1, C2 are pivot columns. Now, what are the pivot number? See, this is a pivot number, this is a pivot element, this is pivot element, this is pivot element. So the reduced row echelon form means you have to convert that matrix such a way that in each pivot column, the element which exists should be one. Again, row echelon form plus few additional operations. operations. You get reduced row echelon form, RREF. We are not stopping here. We are doing few more operations. What is our target here? In each pivot column, the non-zero element should be 1. It's like this example, if you see this matrix, which example I have written here. Sorry. See, in this example, if you see, these two columns are pivot columns, and the element in that particular, the non-zero element, the single non-zero element is 1. Now this matrix can be called as reduced row echelon form. When you convert it this way, it is very easy to find out the solution. Row echelon form, maybe they might have done some little research to convert that row echelon form to reduced row echelon form. Technique what we are applying is Gaussian elimination method. There is no change in that. What is Gaussian elimination method? Apply row transformations. Why are we applying Gaussian elimination method? I want to solve system of linear equations. From where did I get those system of linear equations? From the machine learning data. That ML data, whatever I had, I have transformed them into system of linear equations. That system of linear equations, I am converting them into matrix form. That matrix I am trying to solve using Gaussian elimination method, so that I can find out the values of W1, W2, W3 and so on. Once I find out the values of W1, W2, W3 and so on, I can form a regression equation, which can help me in prediction. I hope you understood the whole picture here. Okay, though this seems very simple and silly to you, still regression is one algorithm in machine learning which is used, and it is solved by using Gaussian elimination method. This is one technique of solving regression, one technique of giving solution for regression, right? I think you got little idea about what you're trying to do here. So Gaussian elimination method, row echelon form, you get solution. You can further convert into reduced row echelon form, and you can find the solution, right? So this is one example. What is the difference between row echelon form and reduced row echelon form? Let's take one more example. Row echelon form and reduced row echelon form. This is very useful when you try to give some interviews where on machine learning, where there are some MCQ based questions. They ask you whether this matrix is in row echelon form or reduced row echelon form. Suppose I have a matrix like this: 3, 2, 5, 0, 0, obviously here, 1, 4 and 6. I have a small matrix. Maybe there are some elements here, 2, minus 3 and 5. Let it be. If you see this matrix, this is in row echelon form because I'm having zeros here. I have reached my target. I am having zeros here, right? So the which is the pivot column? This is the pivot column. This is the pivot column. And what is the element? That non-zero element is not 1. That non-zero element in the matrix is not 1. It is 3. So it is only row echelon form. What is reduced row echelon form? Same thing, same data. If this is 1, and I write remaining things as it is, this is reduced row echelon form because there exists one pivot column and that non-zero element in that pivot column is 1. Then we say it is called as reduced row echelon form. So when you convert a given system of linear equations to a matrix, you try to solve that matrix using Gaussian elimination method. You have to convert that to reduced row echelon form such that you get the solution easily. What is our target? To find out the value of W, weight. Hello. Here, Y. So our target is to find out the values of W, that is X1, XYZ or X1, X2, X3. Okay. So I don't think we need to solve much examples in finding it. I hope it's clear. How do we convert? By applying row transformations. So I have given one exercise for you. You may try that particular solution. Now there is one more technique here. What is the use of this reduced row echelon form? There's one use of this reduced row echelon form. Okay, suppose you are given a matrix. You are given a matrix. I am given 1, 0, 2, 0, 1, 1, 0, 0, and 1, sorry, 1, 2. Just let me do it. Your target reduced echelon form. I am given a matrix here 1 0 2 0 1 1 0 0 1 2 0 1 and I have 1 1 1 1. You are given a matrix like this. One advantage of converting a given system of linear equations or a matrix into reduced row echelon form is that given a matrix, so you can find out inverse. You can find out inverse easily when you convert that particular matrix into reduced row echelon form. How? Just append a identity matrix. What is the size of this matrix? It is 4 cross 4. It is 4 cross 4. See, question is find out inverse of a matrix. There are multiple ways of doing it, but for higher dimension, how you do that? For higher dimension, how you do that? So one way is that you have take the original matrix, append, augment an identity matrix, make it AI, make it a matrix AI. So I will add here what is identity matrix of size 4 by 4, 1 0 0 0 0 1 0 0 0 0 1 0 and 0 0 0 1. I formed an augmented matrix. Now this original one, this matrix, original matrix, you try to convert into reduced row echelon form. You try to convert that into reduced row echelon form. Here you will get the inverse. The result here will be inverse. This is your inverse. Whatever, see, when you are doing reduced row echelon form, you will be doing some row transformations. This also will change. This all values will change. These values get changed and you get the inverse here. Okay, that is one benefit of reduced row echelon form. You can find out inverse of a matrix by forming an augmented matrix AI, where AI is the identity matrix. You apply all those row transformations in this A matrix, whatever output you get in the I, that is your inverse matrix. Okay, so this is about reduced row echelon form. Next concept what we are trying to see is your particular and general solution. One very important concept in machine learning, particular and general solution. Let's see what it is. Suppose given a set of equations, I have 1 0 8 minus 4 0 1 2 12 and I have x1 x2 x3 x4 equal to 42 8. Particular and general solution. We use this when, see, in all the previous examples, the number of unknowns and the number of features are same. It means it's a square matrix. I know the values of, I have a matrix like this 1, 2, 3, 4, 5, 6, 7, 8, 9, and I have x, y, z. Like this, I had one matrix 1, 2, 3. Number of unknowns 3, x, y, z. Number of equations given 3. Perfect. We are able to solve it using Gaussian Elimination Method. This can give me. But sometimes number of unknowns or the number of weights which I have to find out is more. But the number of data set I have is less, like this, only 2 records. This case, you cannot represent the solution. You cannot find out a regression model. Why? So data is not correct. But you can give a particular and general solution. It's a combination. Okay, don't see it as two different. There is no particular solution, there is no general solution. It's a combined word. For these kind of problems where the number of unknowns is more and the number of equations are given as less, then you can find out a regression equation or you can find out a regression model in the form of particular plus general solution. You can give a equation like this. Okay, so how do we do this particular and general solution? Let's see this. To find out, first step, to find out particular solution, convert this given matrix, whatever given matrix with us, into an reduced row echelon form. Convert this given matrix, given A matrix, into reduced row echelon form. If you see, this is already in a reduced row echelon form. Why? I have two pivot columns and the non-zero element is 1. If not, you have to convert it. This is already in reduced row echelon form given to us. Now, you have to take this, when you convert that into reduced row echelon form, you can directly give the solution as something like this. When you have an identity matrix, when you have 48, 8 here, so you take 1, 0, 0, 1, right? And you can have equations x1, x2, x3, x4 into 42, 8. Okay, when you convert that to reduced row echelon form, you can say the particular solution or one possible solution for this given system of linear equations can be simply like this: 42, 8, 0, 0. It can be simply 42, 8, 0, 0. Why? Only when you have an reduced row echelon form here. In such case, since this is x1, this is x2, x3, x4 are assumed to be zeros. Okay, so you can say this is your particular solution. How do we write general solution for this? We'll see more examples. Don't get confused. I'll show you equations with given 3 unknowns, 2 equations, given 1 equation, 2 unknowns. How do we find out particular and general solution? How do you find out general solution now? How do you find out general solution for this? This was the given matrix for us. Sorry. Yes. This was the given matrix. Now see, using x1, x2, you gave one solution. Now let's talk about x3. Let's try to use x3 here. Okay. Using x1, x2, make this x3 as 0. Okay. When I write, you will understand it better. See, I want to make these two values as 0. So let me write it first. See, since this is x1 is 1, I'll write 8. Let us C1, C2, C3, and C4. Column names are given. 8 C1 plus 0 C2 plus minus. I have to do minus here, right? Minus C3, okay, plus 0 C4 equal to 42. See what I'm trying to do? I want to make this 0. I want to use only x1, x2, x3. Both I have to use, but x4 I don't want to, but because using x4 can I do? No, using x4 I cannot do. If I include x4, it becomes complex. So 8c1 plus this 0c2 minus c3 plus 04 means it is 1 here. Okay, not 42, it is 0. Let me write it here 0. See, by doing this, if I multiply these 4 columns in this format, I will get answer as 0. 8c, I want to make x3 solution as 0. So 8c1, okay, let me write for second one also. Let us write for fourth column also. If I want to x4, this is for x3. x4, how can I write general solution? See here, I want to make this, I'll clear it here. I want to make x4 values as 0. How can I make? I can write, since it is minus 4 already, I'll write here 4c1. I don't want to use c2. I don't want to use c3. Here I'll write plus 1 c4 equal to 0. If I can do this way, I'll get the x4 values as 0. See, you try it and see, you'll get these values as 0. Right? Yeah, I will repeat once again. So let us see how are we writing x3 and x4. Very important, particular and general solution. When you are unable to give solution, when the number of equations are given 2, number of unknowns are 4, we cannot find a unique solution. That's for sure. We cannot find out a unique solution because number of unknowns and number of equations should be same. The data should be perfect. In such case, in given this case, you can give solution in form of particular and general solution. You can express the solution as this way. Okay, how do we, let us see how do we find general solution first. Particular solution is very simple. You convert this given matrix into reduced row echelon form, which is already converted. It's already converted. So which all columns, pivot columns, which all columns are pivot columns, that is x1, maybe c1 c2 will take, c1 c2, c1 c2 are pivot columns. Using those, you can simply give the solution as, since c1 c2 are solutions, you can use these two values 42 800 as solution. Why these two I have considered? Because those two are the, suppose we had 6 here, 6 also will come here, 6 also will come here. Okay, so remaining will be 2 zeros, because these two are not pivot columns. General solution, you see, x1 x2 over, those are pivot. Which is non-pivot column? X3. Try to make, see, I will simply say apply Gaussian elimination method for columns, not rows. Previously I was telling you, to solve system of linear equations, use only row transformations, row operations, r1 minus r2, r2 minus r3. Now, reverse case, apply Gaussian elimination method using columns. It means do some column operations and make x3 column 0. That is my target. Which is a non-pivot column, I want to make it 0. How can I make it 0? Using x1, x2 and x4. Right? Understood, right? You apply some column operations, do some column transformations and make x3 column 0. So best way is use x1, x2 easily, because it's identity matrix. Using x1, x2 you can easily do it. How? You see, this is my matrix 1, 0, 8, minus 4, 0, 1, 2, 12. I want to make this 0. This element 0. How can I make it? 8 C1, see, 8 into C1. Second one I don't want to use it. Plus 0 into C2, minus 1 into C3, okay, plus 0 into C4 equal to 0. This is 0. How? You take the first value, C1 value is 1, 8 into 1, 8, plus 0 means obviously 0, minus 1 into C3 means 8, that is minus 8, plus 0. 8 minus 8 is 0, we got it. So by writing this way, I am able to convert the element here in x3, column 3, I am able to make this as 0. Okay, I hope how you got. I am doing column operations, reverse of Gaussian elimination, right? By doing column operations, I am able to make that element as 0. How? So what I did here, 8C1 plus 0C2 minus 1 into C3 plus 0 into C4, right? When you got this, when you get this as your equation, how I am able to make this column value to 0, right? Now you take a constant lambda 1 of 8, right? Only these constant values, 8, 0, minus 1, 0. Okay, lambda 1, I am taking just a constant lambda 1, because we are having infinite number of solutions, no? Because number of unknowns and number of equations are not matching, they are not equal. So you may have infinite number of solutions. In that case, lambda 1 is some constant, which is the game changer in finding the solution. So lambda 1 into, just write these constants, 8, 0, minus 1 and 0. Right? We got this. This is for x3. Now let's do that for x4 also. Column 4 also, let's try to do it. I know there are a lot of solution is not yet over. There are a lot of challenges here. 8 x4. If I do, I want to make this as 0. I want to make that element as 0. So what can I do here? For x4, if I want to make this 0, I can use 4 C1. I don't want to use C2. I don't want to use C3 also. I want to use 1 C4, so that it becomes 0. See, 4 C1 means 4 into 1, yes, 4 plus 0 plus 0 plus 1 into C4, that is minus 4, it is 0. So I got one solution here, right? So I can represent this as another solution. Let me take lambda 2 into, just write these constants, 0. So it is 4, 0, 0 minus, it was 1, right? 1, 4, 0, 0, 1. This is one, no? C2. Yeah, that will make it correct. I have to use 12C2 to make this also 0. Correct. So 12C2 minus 12C2 I can use. 4 minus 12. Yeah, I think minus 4, 12 and 1C4 equal to 0. With this I can make, right, I can make this second one as 0. Right? So you got. Now how do you represent this? When you are making using column operations, when you are making it 0, your particular and general solution will be something like this. You have to represent it in this form. So particular solution we got 42,800 plus lambda 1 into previously we got 80 minus 10 plus lambda 2 into 4 minus 12 0 1, something like this. So this is your particular and general solution. Okay, this is a mathematical thing, nothing to do with much with regression, but sometimes in interviews they may ask you what is the particular and general solution for a given system of linear equations. Your number of features are more, you want to form a ML model, but to form a ML model you need to have a non-singular data with you, data which is complete information, but you have incomplete information. This lambda 1 lambda 2 are constants. Varying values of lambda 1 lambda 2 will give you different solution. You put lambda 1 as 1, lambda 2 as 1, you get one solution. You put lambda 1 as 2 and 2, you get different solution. You get 3 and 1, you get different solutions. Since it is infinite number of solutions, this is what we get. We are representing a generic form, general solution. We do not know, we have, for these equations, we have infinite number of solutions. So any value of lambda 1, lambda 2, it can be any number, any integer you put for lambda 1, lambda 2, you will get different solution. Okay, lambda 1, lambda 2 can be any value. If you put lambda 1 as 3, lambda 2 as minus 3, you get one solution. You put lambda 1 as 10, lambda 2 as minus 15, you get one more solution. So for any lambda 1, lambda 2 are constants. They can be any values. They are variables, right? Yes, L1, L2 is the system for given L1, L2 represent x1, x2, x3, x4. Yes, you have to combine this. You have to combine the solution, then you get x1, x2, x3, x4 values. Since we have infinite solutions, for each different value, you get different solution. Okay, so this is your particular and general solution, right? So we have one more thing, minus one trick. So the next concept is minus one trick. Just listen. Yes, minus one trick. What is this minus one trick? Let's see. Suppose you are having a given problem, minus 1. If I give a matrix 1, 3, 0, 0, 3, 0, 0, 1, 0, 9, I have 0, 0, 0, 1, minus 4. Okay, I have a matrix like this, right? Now, I want to see number of equations, number of unknowns are different. Definitely infinite number of solutions, right? So, you can give only a particular and general solution. You can give particular and general solution for that. But what is minus one trick? For this matrix, what you can do, add, is this in 5 by 5? Is it in 5 by 5 form? No. Convert this matrix into a square matrix. Convert this matrix into a square matrix. It is not in square matrix. It has 3 rows into 5 columns. So 2 more rows are missing. I want to add 2 more rows for this. How can I add 2 more rows for this? See how I'm adding it, 2 more rows. First one, 1, 3, 0, 0, 3. Observe the identity element. See the diagonal matrix, the diagonal element should be either 1 or -1. The diagonal element should be 1. See here, second, this is fine. First element is 1. Okay, second row, here do we have 1 here? No. It means 1 row is missing in between. 1 row is missing. So that row I will include like this, 1, -1, 0, 0, 0. I have added 1 row here, a new row. Third one, you see, this row I can take as it is, 0, 0, because I have 1 here. I have 1 here, 0, 9. See, diagonal element should contain 1 or -1 only. That way you have to convert this given matrix into square matrix. Okay, but again, I have directly jumped into solution. Given system of linear equations, convert that to matrix, convert that matrix into reduced row echelon form. After converting that to reduced row echelon form, you can find the solution. But if the number of equations are less, still you have to try to convert that into reduced row echelon form like this. Okay, so this has been converted into some reduced row echelon form. Now this is okay. Now the fourth element should be 1. Yes, I have a row which has fourth elements as 1. So 0, 0, 0, 1 minus 4. Now go to the last one. Do we have another row here? No, I have to add one more new row. 0, 0, 0, 0, minus 1. Now this matrix became a square matrix. So this 3 by 5 matrix, I have converted into 5 by 5 matrix by inserting 2 new rows. Where did I insert? Wherever the diagonal elements were missing. Like this was missing. We did not have proper ones and minus ones in between. So I have added a new row here and I have added a new row here. Okay, so this way you converted it. Now, once you added new rows to this matrix, it became just convert it. Yeah, one question. Yes. But even if you convert this 3 to 1, I understand. If you convert this 3, sorry, oh no, this 3 to 1, but still, this is a pivot column, but we are not having a square matrix. I want that element to be, I want to form a square matrix. Okay, when I want to form a square matrix, that is the trick actually, -1 trick. Okay, if you, maybe I have to explain once again. If you, for this given matrix, if you try to write particular and general solution like the previous one I explained, right? C1 minus 4, C2 plus 4, C3, you get some particular solution plus lambda 1 into general solution plus lambda 2 into general solution, right? You get this form. How did you get these things? By doing the column operations. Instead of doing all this work, just convert this matrix into a square matrix. That's what -1 trick means. Include, convert that matrix into square matrix. If some rows are missing, include some rows. In that, try to make sure that there are diagonal elements. There are at least either 1 or -1 in the diagonal. Maybe your question is already in the given question, already in the given problem, if there exists a -1 here. If there exists a -1 here, I have no problem. So first row is clear, second row is clear, third row is missing. I have to insert third row. Fourth row is fine, I have to insert fifth row. That way you have to insert it. Okay, right? So insert new elements into rows such that it becomes a square matrix. How do you insert new rows into that? Such that the diagonal element should be ones and -1s. If maybe one more question you may say, sir, I have a 5 by 5 matrix already with me. I have a 5 by 5 matrix already with me. Check the diagonal elements. If they are ones and -1s, okay, stop. If not, you do row operations. If the given matrix itself is a 5 by 5 matrix, you will get the solution directly. No, we don't have to do all these things. We did not have to find out particular general solution. Definitely, the number of rows will be less. You have to increase more rows. How to increase more rows? Such that diagonal elements are ones and minus ones. I have inserted now ones and minus ones. After inserting ones and minus ones in the matrix, now whichever column is having minus one, which you have inserted. See, this minus one I have inserted, this minus one I have inserted. These two columns are your general solution. So you can simply write lambda 1 into C2 plus lambda 2 into C5. That is a general solution. Understood? You need not do any column operations. If you want, you can try to solve it and see. Our previous problem, if I take this data 1, 3, 0, 0, 3, and then I have 0, 0, 1, 0, 9, and then I have 0, 0, 0, 1, and minus 4. So here in this C2 is not pivot. This is not pivot. I have to convert this to 0. How do I convert? C1, 3C1 minus 1 into C2 plus 0 C3 plus 0 0 equal to 0. Correct? By doing this, I can make this particular column to 0. 3C1 minus 1 into C2 plus 0 into C3 plus 0 into C4 plus 0 into C5. Correct? So I get a value as, what do you get? 3 minus 1, 0, 0, 0. See, this is lambda 1. This is your solution, no? That this same we are getting using minus 1 trick. Right? Even this is pivot, this is pivot, this is not pivot. Convert this to some equation. How can you do this? How do you convert this to, how do you make it 0? Do some operations. What can I do here? Using C1, C3 and C4. C1, C2, C3, C4, C5. I want to make C5 0. How can I do? To make 3 to 0, I can write 5C1. Then to make 9 0, I can write plus 9C3. I don't want to use C2 here. Or if you want, you can write 0 C2 plus, I want to make this 0. So already it's minus there. So I'll write here. Okay, I can write plus 4C4 equal to 0. C5 is missing, no? Yes. So I can write minus C5 equal to 0. Okay. For that I'll write minus here. Yes. This way, if I do 5C1, 5 into 1 minus 3. 3C1, 3 into 1 minus 3, 0. Then 9 into this minus 9, 0. That way you are getting 0. So what is another solution here? 3, 9 minus 0. Sorry. It is lambda 2 into C1 means 3. C2 is not used, so 0. Then 9, then minus 4, then minus 1. See, we added minus 1 now. In the last column, last row I have added minus 1, if you remember. So using minus 1 trick, directly you are getting general solution. But just by including 2 new rows into the matrix, making that matrix into square matrix. Okay. Yes, same case, we can do this minus 1 trick. You can apply it. Good question. If you have less number of columns, more number of rows, what can we do this? Right? Same way, you have to include, what you can include, you have to include more columns to make it a square matrix. Yes, you have to do in the same way. Like here, you are adding more rows. In that case, you have to add more columns. How do I have to add more columns? Such that I get diagonal elements as ones and minus ones. In that way, you add it. Then you get a solution. Okay, that is minus 1 trick. Is it clear? Right. So if you summarize what we have seen in the second half, we have seen different kinds of solutions. That is unique solution, infinite number of solution, and no solution. Then we have seen Gaussian elimination method. You can perform row operations in each of those rows and find out, convert that into row echelon form. Advanced version, you can do it into reduced row echelon form also, so that you have to do lesser number of equation solving and get the solution easily. Then we have seen particular and general solution, but also can be given using minus 1 trick. Right? So with this we complete how do we solve system of linear equations. If I again recall completely as overall, you have a ML data with you, limited data, small size data can be converted into system of linear equations. That system of linear equations can be represented as a matrix. Why I am converting into matrix? I want to solve those system of linear equations. Why do I have to solve? So that I can find out the unknown values W1, W2, W3. My target is to form a regression model which can help me in prediction. So ML data converted to system of linear equations, converted into matrix form, applying row transformations, Gaussian elimination method, converting into reduced row echelon form, finding out the unknown values W1, W2, W3, so on, and forming a linear equation, forming a regression equation, which can help me in doing prediction. Okay, so I hope you understood this part, right?